Hello, everyone. My name is Dr. Charlene Ortiz, and today we're going to be talking about scientific measurements. What I mean by that, we're going to cover topics such as methods, variables. We're going to talk about operational definitions. We're also going to talk about data scales, particularly scales of measurement, including nominal data, ordinal data, and things of that nature. We're also going to talk about their pertinence when it comes to the social sciences, but particularly focused to psychology. So let's get started. So one of the things that I like to mention, and something that we should discuss in detail, is the definition of variables. When I'm talking about definition of variables, we're talking, of course, of two main variables that we're going to see more than likely in social sciences. So the first variable that I like to talk about is constants, right? And what do I mean by a constant variable? It's a variable that will remain the same. It's a number that will always remain consistent or constant. So for example, many of you, if not all of you, are familiar with pi. So in this specific case, we know about that pi equals 3.14 and so on and so forth. We also have Weber's constants. And this is basically a constant, a number that remains the same when we are talking about sensing or being able to perceive a difference in stimuli, right? So to give you an example, there's on occasion, say, for those of you who walk into a classroom and something may smell awful, right? But before that, for a while, you didn't notice that something smelled awful. That is because there was a minimum level of that stimuli that was needed in order for you to detect that difference that went from something not smelling awful to something indeed smelling awful. So that number will remain the same. So that's another example of a variable that is constant. Now, what is a variable? A variable is any characteristic. We can think about, for example, anything can change over, say, for instance, different people, or it can change from one situation to the other. So generally, these are characteristics that will vary. So for instance, let's think about a couple of examples. So we can have, for instance, height, IQ, blood pressure. We can have also other characteristics that can vary from one situation to the next. So let's think about stress, the type of stress that you may rate a situation to the other. For instance, the stress level that you can feel in a classroom, I should say, versus the stress level that you may feel, let's say, in a police station, right? So that's something that the situation, the variable of stress will be different based on the situation. We also have memory recall. And in the sense of memory recall, let's think about how difficult it might be for you to recall something during an exam, or for you to recall something, say, for example, while you're being pressured in an interrogation, right? So those two situations, even though we can think about memory recall being the same variable, but our response to that will be different, which means that both stress and memory will vary depending on the situation. Now, something that I need to mention is what makes a variable scientific. What makes a variable fall within the concept that we can study it? Well, some of the things that are necessary in order for us to study a variable is that we need a variable to be observable. What do I mean by observable? One of the things that we need to understand is that in order for a variable to be observable, we can have either the direct observation of measurement, Or we can also have an indirect measurement. One of the examples that I like to mention is that a lot of people would say, well, I can't see sadness, right? So let's suppose that some people would say, I know when a person is sad because they're crying. Well, see, the problem with that is that we can also cry, say, for example, out of happiness. So because we can have an indirect measurement of a variable, doesn't necessarily mean that that is the variable that is trying to measure. Now, keep in mind, these will become inferences of that main variable. So let's think about a direct measurement. So a direct measurement, as I like to think of, is anything that I could actually record, right? Something that I can actually record with a video camera, or we can actually see it happen. So some of the examples that your slides mention is, let's say, the number of mouse clicks, right? So think about how many clicks you will do during an exam versus how many clicks does a person click on their computer while, for instance, watching pornography, right? That's something we could actually see and record. Another example is that of the dilation of pupils, right? We can actually record that. However, in social sciences, it's not as clear cut, is it? Because in social sciences, what we come across is that generally we have to rely on indirect measurements. So as I mentioned earlier, we can't really record sadness, can we? We can associate behaviors with sadness. So for example, frowny face, an individual crying, but I cannot record sadness, I should say, directly. So for example, I can tell you what color sadness is. I can't tell you, I cannot grab this can of soda and hand this to you and say, here's some sadness, here's 10 ounces of sadness. Right, because it is an indirect measurement. So in social sciences, we rely on these measurements. We rely on indirect measurements most of the time. Now, another characteristic of scientific variables is that we must be able to replicate that instance that we observed. So for instance, I should be able to replicate, I should be able to see time and time again this variable. If I am not able to see the same variable, engaging in the same statistical measurements, engaging in the same methods during my study, there is something faulty, whether it be with the actual methods, deception, fraud, issues with statistical measurement. So notice that these issues can happen because we're not able to replicate that data. So in order for a variable to be scientific, we expect it to both be observable, and also we expect it to be something that we can replicate. Now, something important about variables is that we need to be able to define this variable. And this is where the topic of constructs comes into play. Now, what is a construct? A construct is something that I am able to conceptualize. it's something that I am able to define as a means of measurement. And I'll give you a very easy example. So for instance, we can conduct a study, right? We can conduct a study of, say, love between couples, right? But if I were to take a survey here and say, let's define love, many individuals will define love differently. So for instance, some students may say love in between a relationship is the engagement of how many times they engage in intercourse. Or some people may say, well, love within a couple is how well do they treat their children. Somebody else may define love between couples as how much are they able to share their thoughts and opinions and desires and needs. So notice that we need to define constructs because we need to have a method to measure it, to detect it, and measure it. So without the definition of a construct, I wouldn't be able to measure that particular variable. So let's think about some examples. We mentioned love, but notice that here, we also have in your slides, we have intelligence. So what is intelligence, right? So we will need to define that construct just like we did love in order to be able to detect it and measure it, I should say, accurately. Or altruism. What is altruism, right? Is it how much money does a person give to charity? Is it how much a person decides to give their time to others and charitable organizations? Now, something interesting about a construct is that we also see the external factor of a construct. What do I mean by the external factor of a construct? So what we're looking for is the observable behavior or an event that it's presumed to reflect that construct. So let's think about that for a second. Presumably, when we are sad, we cry, we might stop doing things that we normally enjoy, we stop seeing things as pleasurable. But ultimately, we cannot be 100% sure that those characteristics reflect that intended source. So for example, sadness. That is why we will need to define that construct. So for instance, if you are studying religion in one of your experiments later on or questionnaires, think about, okay, so how am I going to define religion? Is it organized religion? Is it tax-exempt religion? Do spiritual beliefs come into play? Am I only going to focus on Judeo-Christian beliefs? Am I going to focus on religions that are more of the Middle Eastern origin, I should say? So notice that we can define a term with the intent that we're trying to see whether or not that reflects the behavior that we're looking for. Something interesting that I should mention is that not only do we have to define the construct so that we know what it is reflecting. We're trying to understand, I should say. But we also have to have a method in which we are going to measure that construct. So in this particular case, let's think about how are you going to measure love, for example. How are you going to measure love? So if you're conducting this hypothetical study that I was talking about how we're going to define love in between a couple, how are you going to measure that? So first you would need to define it in order to measure it. Similar to hunting. If I ask you to come hunting with me, but you've never seen a duck in your life, how are you going to shoot and aim for that target? In the same fashion, we define constructs, but we also need to understand what type of measurement. We need to define that measurement in order to see whether or not it does reflect, and it's an accurate measurement for that variable. So let's look at our example. Say, for instance, the construct here is anger. Excuse me, I should say hunger. So when we're thinking about hunger, first of all, we would have to define what hunger is. That's why we focus on the construct of hunger as a construct. So in this case, this model here is showing you that they decided to measure the construct of hunger based on the food intake. That's how they decided to define their construct. Now notice, as you see here, notice that you will have, for example, this individual decided, okay, well, I'm going to measure the food intake based on grams. Another form of measurement could be, I'm going to measure food intake based on calories or self-report. Notice that if you paid attention or have seen the previous videos about validity, these have a face value of being accurate measurements of hunger, right? We would conclude that the more grams you consume could be a reflection of your food intake and ergo about your hunger, right? So they seem to be valid. They actually seem to measure what they are intended to measure, which in this case is food intake. But we would have never gotten to this particular measurement if we hadn't defined hunger as a construct. Now, interestingly, we also have operational definition. Right? We have operational definition. And what we mean by that is how is this external factors, for example, hunger, anger, love, sadness. We're going to take this construct and actually define that operation, right? That's why it's called operational definition. We're going to define that operation as a means to manipulate that variable. So for example, let's think about hunger. In the example that you saw previously, we can manipulate food intake. I can describe it, come up with a method that's going to be geared in regards to how much food or how much a person does not consume. The other aspect about an operational definition is that you can actually describe the operations for measurement. So what do I mean by that? In regards to hunger, in the example that you saw earlier, we can think about the calorie intake, and there's ways to measure calorie intake. Or say, for example, based on grams, right? I can physically record how many grams of food are you consuming. I have to conduct an operation, an action, as to how am I going to measure the grams of food. So for example, am I using a scale? What type of scale? How accurate is this scale? Is the scale used for food or for something else, right? So you can actually get really into detail, which is what's recommended in order to replicate your study later on. So it is actually recommended that, of course, you go into deep detail as to how you're going to conduct these operations, that operational definition. Now, when we talk about when we're going to manipulate a variable, as a reminder, we manipulate the independent variable. So when we're conducting an experiment, remember that the variable that you will be manipulating will be that independent variable. Problem is in social sciences, sometimes we cannot manipulate that independent variable directly. So that's when we come into the quasi-experimental approaches, right? And if you watch the previous videos, you know that means that we don't have a direct manipulation. So for instance, the independent variable is trauma based on a car accident, right? It will be unethical, if not illegal, for me to put a participant in a car accident, right? So we technically cannot manipulate that variable, but the next best thing would be to survey or conduct a questionnaire with people who have indeed been in a car accident. And there we go with the operational definition. What's a car accident? Is it a fender bender? Is it a total loss? Is it anything that caused the loss of consciousness, I should say, right? So that's when we go back into that construct definition. So something, for example, another example that we can have in terms of manipulating an independent variable is drug usage, right? So we can focus on that too. We can measure drugs based on milligrams, kilograms, time intervals. So those are other things that you could see in terms of manipulating that variable. By the same token, remember that the dependent variable, as discussed in previous videos and previous lectures, is that dependent variable is the one that depends on the independent variable. That's the one that instead of manipulating, we are trying to measure. So for example, talking again about that independent variable of a car accident, trauma because of a car accident, I'm trying to measure, say for example, panic attacks. It's a diagnosis, right? So for example, I would conduct a measure, for example, assessment of, say for instance, the amount of anxiety types of symptoms that this person has experienced because of that trauma. So notice that with that dependent variable as a review, remember that what we're talking about is the ability that we have to measure that variable. Now let's look at types of variables. Let's look at types of variables. Something about the types of variables is that there are different kinds depending on their characteristics. For example, the first one that we're going to talk about is a continuous variable. This simply means that this variable is measured along a continuum. So basically, any point or any number after the decimal point. Another characteristic of a continuous variable is that a continuous variable also can be measured as a whole or as fractions. And that's immensely important for you to recall. So a good example is money. Money is a good example of a continuous variable, right? 25 cents a quarter, it's a fraction of a dollar, right? It's 1/4. So I can actually demonstrate and show you that that measurement can also be shown in fractions, but it's measured along a continuum. Another example is the time that it will take an individual to sprint, right? 100 meters. And so that's another example of a continuous example. As I mentioned earlier, your income, right? Money. Another type of variable is the discrete variable. Now, the first thing to note about a discrete variable is that this discrete variable is not distributed along a continuum. Generally, a discrete variable, I want you to think about a go or no-go situation. Right, so let's think about this. This female here who appears to be pregnant. That will be a form of a discrete measurement because you're either pregnant or not. You can be half pregnant. So there's the fractions in a discrete variable are not possible. So I want you to think about discrete variables as a means of a go or no go. Either she's pregnant or not. Generally, we like to think about these as categories, right? And there are many interesting examples of what a discrete variable is. So let's think about number of siblings, right? You have 3 brothers and 3 sisters. Now, you might have heard at some point, well, the average American household has 2.3 kids. Ideally, most of you know that you can cut your brother in pieces, right? Hopefully. That's not an idea that you have in your head. So that 0.3 is actually meaningless. A better way to present that data will be, say, an average, right? A median. Those would be better methods, better ways to describe the average number of siblings or children in a household. Socioeconomic status. That's also another method. It's also another way to see a discrete variable. So for instance, think about categories. You're either low, middle, or high when it comes to a socioeconomic status. And the last example that I like to mention is the eggs in a carton. Either you have a whole dozen or you don't. Now, notice that some of our measurements can be quantitative in nature. Now, we have covered this in other videos and other lectures, but let's review them and let's go a little bit into detail of what these mean. So for example, when we think about quantitative, I want you to think about quantity. Quantity is generally represented in numbers. So generally, it's a numeric value, right? There is a number that we're going to look into. A quantitative value will be measured in numerical units. We can both have continuous or discrete variables that can be quantitative. Now, a quantitative value, or variable, I should say, can be your food intake, right? So differences in these numbers actually have a meaning, right? Unlike the 0.3 siblings of the example that I gave you earlier. So for example, if you have one serving of pasta, you have two servings of pasta, having those two servings actually makes sense because we can draw the conclusion that you will have twice as many calories. So notice that that difference is, it does actually have a meaning. Now let's think about candy pieces. It's a quantitative variable, I should say. So in this case, you can have a certain amount of gummy bears or M&Ms. And we know that this amount will be either you had M&Ms or you didn't. Now, another thing that I would like to talk about is conversely the qualitative variable. When we are talking about a qualitative variable, we are talking about a class or a category. This is a discrete category that we generally use to define behaviors. So in this case, we can only have discrete variables. They can only be within the qualitative measurement. So qualitative variables will always be discrete. And a really interesting example about a qualitative measurement is, for example, depression. We look at mental illness as a form of categories, right? So we have our mood disorders. We can have learning disorders. So notice that we're going to have different categories. So in this case, depression is a good example of a qualitative measurement, or qualitative variable, I should say. And you may be wondering, well, I can tell if someone has more depression or less depression. Notice that we will assign numbers to qualitative characteristics. But keep in mind, these are simply so we can understand, say for example, when you put depression in a computer, right? You do a rating scale or the Beck anxiety inventory or Beck depression inventory. We're doing this with a client or a patient. You can tell, well, this guy has a number 20, so he must have X amount of anxiety, or this guy has a 5, so this guy has X amount of depression. But notice that they remain to be categories. You either have depression or you don't. That number is simply to gather an understanding, but it's an artificial number because, as we learned, qualitative variables remain to be categories. A really good example as I demonstrated, is categories of psychological disorders. So in this case, for example, we have eating disorders. They are a category. We have anxiety disorders. They're considered another category. Now, some of you may wonder, well, you know, if you painted a house or if you changed the color of something that you've used before, you'll say, well, colors have a hue, right? They have a number. So if I say number 5.73, that means navy blue. Notice that you're only talking about the category of blue. So that number that we assign is simply artificial. The next thing that I would like to talk about is data scales, the scales of measurement. Scales of measurement are simply rules they are simply rules as to what or how the properties of numbers change based on their usage. And in this sense, we like to describe them based on the information that we can gather through our measurements. So this is a really nice acronym. I would say NOIR because NOIR, it's black in French, the color black. So that's a good way to remember what the data scales are. Just remember that NOIR means black, and you might remember later on for study purposes. So the first one that I would like to talk about is the nominal categories. So in the data scales, the nominal scales is when a number is going to represent a category. But notice that it's not going to provide you any additional information. So in this example, the example that I have on screen, notice that we assign a number 1, we assign red as number 1, 2 is for blue, 3 is for green, and 4 is for yellow. So it's only representing a category. It's basically putting this data inside a bin. But 4, 3, 2, 1 are otherwise meaningless. Does this mean that 1 is better than 2, so that red is better than 2? Or is 2 better than red because it has a 1? So notice that doesn't make sense, right? That number doesn't provide a meaning necessarily, but we're simply assigning these numbers as a means to put things in categories. So in this sense, another example is coding men as a number 1 and women as a number 2, and then non-binary perhaps as a number 3, and so on and so forth. But that is simply to put something in a bin, in a category. It doesn't mean that number 1 for men and the number 2 for women and so on and so forth doesn't have any inherent value, does it? We're simply coding. We are simply assigning a category, putting these characteristics in a bin. Now, something that we need to talk about is ordinal scales. Now, in this particular regard, I want you to think about ordinal as order, right? When things are in order. So because something is in order, it's simply showing me the rank of something. It's not showing me any other more detailed information other than there is actually some meaning to the order, right? Unlike our previous example, where 1, 2, and 3, this order is meaningless, right? It doesn't mean that 2 is better than 1 or that 1 is better than 2. Here, there is a meaning. The order actually has some intent to represent the measurement. However, it doesn't mean that it implies a degree of difference. So let's think about an example of your place in a race. Say you were running and then you came in third place, right? You came in third place. Coming in third in a race doesn't tell me much, does it? It only tells me that you were third in an order of 1, 2, 3, and say, for example, 100 runners. It doesn't really tell me much, right? It doesn't tell me if you're a male or a female. It doesn't tell me how fast you were going. It doesn't tell me your velocity, your speed. It really doesn't tell me much, other than you came in third in comparison to, say, for example, 100 runners. So it simply gives me an idea of an order, but not necessarily everything else. Another form of data scale is that of interval scales. So let's think about these differences, right? So now the number is actually meaningful. I can actually start looking into what does this number mean within that explanation, within that measurement. Notice that in this particular example, there is no true zero. Right? So when we say in Fahrenheit, there are other measurements that there is a true zero, but let's think about Fahrenheit first. So in Fahrenheit, 0 degrees Fahrenheit doesn't mean that there is no temperature, right? That's not what that means. Because there is no true zero in this particular measurement. Now, something interesting about interval scales is that the distance between the numbers on this specific scale are equidistant, which means that if I have a difference, that difference actually means something. So for example, the difference between 40, 50 will be the same as the distance between, let's say, 30, 40, and so on and so forth. So we do know that there is an equidistant in distance, I should say, in that scale. Something that you're going to see often in the social sciences is the Likert scale. Basically, we say the common example of a Likert scale is don't agree on all, somewhat disagree, I'm neutral about this stance, and so on and so forth. Now, the last thing that I would like to talk about is ratio scales. Now, within ratio, I should say, scales, they're very similar to our previous interval scale. But the main difference in this regard is that they actually do have a true zero. Zero means nothing, right? It actually means none. It actually means zero, as you and I commonly understand it, right? They're also equidistant, like our previous scale. And some examples of this could be time, length, height. Zero actually does mean zero. And the difference between 1 foot and 2 feet is the same between 2 feet and 3 feet. So notice that we also have an equidistant relationship, or rather I should say characteristic, as to not to confuse anybody. And they have a true zero. Now, how exactly do we go about measuring these variables, right? What do we do, particularly in social sciences? What do we do to actually measure these variables? Well, we're going to review different types of measurements. And I'm sure a lot of you are familiar with this, filling in the bubble. And for those of you who later move on into practice, you're going to come across the MMPI, which is closer to the 600 questions. So you can fill up that bubble, those bubbles 600 times. Now there are three ways that we're going to talk about that we can actually record and understand this data. How are we going to measure it? The first method that we can utilize to measure a dependent variable is the self-report measurement. In this case, you will have the subjects respond to one or more questions. Generally, you'll see that in a psychological instrument. So, as I mentioned, the MMPI, the PAI, personality assessment inventory. Generally, in these self-reports, you're going to find that these self-reports are interested in indicating your experiences, your attitudes, your opinions, right? So in that self-report measurement, you can say, or ask individuals, how likely are you to hit your spouse? How comfortable do you feel with the idea of hitting your spouse? And an example of a potential question like that would be like, I would like to hit my spouse. Do you somewhat agree, somewhat agree, neutral, somewhat disagree, don't agree at all? There are multiple advantages to this specific method of collecting data. First, it is immensely easy to collect data in this fashion, right? You can put up a survey online. I'm sure many of you have completed surveys online. So it's immensely easy to distribute. It is immensely easy to collect once you're done. And because it is so easy, it's also cost effective. So you can put up a survey for free on a website and have dozens, if not hundreds of people reply to that survey or that questionnaire. The problem is that there are several disadvantages with self-report measures. So let's think about the example that I just gave you, right? How likely are you to hit your spouse? How likely are you to hit your boyfriend or girlfriend or other, or your significant other? The problem is that self-report measurements can be inaccurate. The first issue that we may have is how we develop each question is immensely important for validity. So when I say, I would like to hit my spouse as an item, as a question, to gather a response from the participant, notice, am I really measuring domestic violence? Right. So is this an accurate, valid instrument or question? When we are constructing that measurement, am I really talking about, say, domestic violence? Not necessarily, right? For all I know, right, when an individual is responding to that item, they can be talking about playful fighting. They could be talking about a sexual behavior, right? So for all I know, when they're responding, yes, I agree with that statement. I would like to hit my spouse. Is it truly for domestic violence? Is it violence in general? Is it some sort of playful sexual behavior that they have, right? So notice that would be the first limitation. Whether or not that question, that construct, how the instrument or the measurement was developed, was it actually valid? And the second point is that when we do self-report measurements, we want to be socially desirable, even when you conduct a self-report with complete confidentiality or anonymity, even when you're guaranteed being a complete ghost, if you will, people still want to respond in a socially desirable, I should say, socially desirable fashion. So if I'm responding to this survey, I would like to hit my boyfriend. I would like to hit my girlfriend. I would like to hit my spouse, right? If I'm responding to that, I am responding of the idea of me, what I would like to look like, but not necessarily what I actually do, right? Most people wouldn't admit, yeah, I want to hit my spouse, my boyfriend, my girlfriend. So most people wouldn't want to admit to that. So maybe they'll say something like, I don't want to admit to myself that that's what I would like to do. So let me put disagree or somewhat. Even if they're guaranteed complete anonymity with their response. Now, here is an example of a very popular and well-validated inventory. The Big Five inventory. So in this particular inventory, we ask the individual to rate and select based on this Likert scale. We're asking them to show whether or not they disagree strongly, agree strongly, or somewhere in between. So for instance, there are some that already seem as socially desirable. But then remember that when we're answering things of this nature, we generally want to present ourselves as the idea of ourselves, what we would actually like to look like, but not necessarily how we truly are. Now, another way we can measure that variable is through a behavioral measurement. A behavioral measurement. Now, this is what I like to refer to as something I can directly record with, like, say, for example, a video camera. Why do I say that? It's because we can directly observe and record that behavior. Right, so I can use, for example, if I want to measure their heart rate, if I want to measure your blood pressure. If I want to measure how many times you blink while in a lecture, how many times do you fall asleep in a lecture, right? So that's something I can actually record. There's measurements for blood pressure. There's measurements for your heart rate. I can literally count how many times you fall asleep in class. So these are behaviors that I can actually record. But there are two things that we need to think about when considering that direct observation. First and foremost, if you recall from earlier, we need to define that behavior, right? That variable. We need to make sure that we have conducted an operational definition for this variable. So the way that we record something is going to depend immensely on how we define it. How are we going to record it if I don't know what it looks like? I don't have a definition for it. Just like the example that I gave you earlier. How are we going to go hunting for ducks if you've never seen a duck in your life? Now, there are multiple advantages to behavioral measurements. First, is that it is more direct. That self-report that we were talking about earlier. So you can say, in that fictitious assessment, I would like to hit my spouse, and you wrote strongly disagree. You selected strongly disagree. But then if we actually counted the amount of times you've had, for example, some domestic dispute, that is an observation of your behavior. And it could be a little bit more direct than that self-report. Because you may say, I don't want to hit my spouse, but it turns out every week, police shows up because of a domestic dispute. Right, so it's more direct than our previous self-report measure. The problem with a behavioral measure is that there are ethical issues regarding what can and cannot be observed. So let's go back to our example. How ethical of me would it be if I monitor this one couple, right? And by monitor, I mean record and things of that nature. How ethical would that be if I get involved in their private, marital life, home life? How ethical would that be if I just start seeing and recording and going into their home so that I can gather my behavioral data, right? How many times did she slap him or he slap her and vice versa? So that's the first concern. So how ethical, what can be measured, what can in fact be recorded? What can actually be observed without it being a problem? Think about sexual behavior, right? We can say, an individual can say on a self-report, let's think about intercourse. So let's think about this person saying, I have never had sex with the same sex. But then in a behavioral observation, we notice that this person has indeed engaged in sexual behavior with the same sex. How ethical of me would it be to record that sexual encounter, right? And actually, one of the most controversial studies involved precisely that. A practitioner, a researcher, directly recording participants having sex. That was an immensely controversial research. It was actually immensely insightful, but of course there's ethical concerns with that type of action. Now, another issue is that some constructs lack an obvious behavioral measure. So think about our earlier example earlier. right? What I mentioned earlier, I should say. I want to know how couples love each other, right? So psychologically, mentally, very easily, I can define what blood pressure is. I have reliable and valid instruments to measure blood pressure. In the psychology sciences, on the other hand, psychology is a science and other sciences. If you remember from earlier in our lecture, if you remember, we talked about indirect observations, right? We infer that this behavior reflects that psychological construct. How many times a couple hugs each other equals or equates how much they love each other. But notice that I depend on a definition to say, this is my definition of love, how many times they hug each other, so that I can measure. The problem is that we lack sometimes an obvious behavioral measure. How do I measure love, right? Particularly in the social sciences, you will come across that concern more than you do in the hard sciences. And as a note, that is why psychology is classified as a soft science, because it has less of that direct observation and it has to rely more on the indirect observation. So that's a little side note. The last measurement that I would like to talk about is the physiological matter to measure that dependent variable. In this regard, let's think about the responses of the brain of a human or an animal. So, for example, we know that we have a general idea of what normal behavior is, right? So if I have a general idea of what normal behavior is, I can actually start measuring, say, a disorganized physiological response. So for example, an MRI can show me what a normal, common brain looks like and reacts versus an abnormal brain. I can actually look at that in a physiological sense, right? And neuropsychologists can show and demonstrate that because it is a physiological measurement. Another way would be, say, for example, the amount of cortisol in your blood. And as we know, cortisol is related to stress level. Now, there are multiple advantages to this approach. The advantage is that it does require a very careful collection. It's a very careful procedure. And there's a lot of resources that have been shown to be valid in the past. So like I mentioned, very reliable measures of how to test your blood pressure. The disadvantage, however, is that it's generally expensive. The training is expensive. It is time consuming. The instruments are expensive. So notice that there is a lot of preparation when it comes to this type of measurement. A neat example is a polygraph. A polygraph is geared towards measuring physiological responses. For example, heart rate, blood pressure, your respiratory rate, muscle tension. And of course, we're not going to get into the debate of whether or not they are reliable. That is because that would be a whole lecture in and by itself. But generally speaking, very briefly, they're not considered an accurate measurement of lives, because you can say it's an accurate measure for heart rate, it's an accurate measure for blood pressure, and so on and so forth. But is it really telling me if someone's lying? Well, it's telling me that there's a change in their heart rate, but does that equate to lying, right? I can have a change of heart rate if I see someone I haven't seen in a long time, right? Say I'm walking on campus, and I see Petey. Hey, I haven't seen Petey in forever, right? My heart rate is going to change. Does that mean I lie about anything? Of course not. So that's where the debate comes in, whether or not polygraphs are actually valid. Are they actually measuring lies, or are they simply measuring physiological changes, i.e. heart rate, things of that nature? Now, this will be the end of our lecture. I hope that this was informative, and I hope that you enjoyed this type of format, and thank you very much for your time.